Hello everyone, good morning. How's everything? I hope you are feeling well today. Let me introduce myself. My name is Ni Made Ewik Diantari and you can call me Miss Ewi. Today we're going to talk about sets in math. Let's get cracking. So discussion today is first sets definition, second representation of sets, and third types of sets. Okay, a set can contain anything, be it a collection of numbers, days of the week, fruits, etc. A simple example is a set of positive integers up to 5, which looks like this. Okay. But exactly how do we define and use sets? Okay, let's take a look. What are a set? Okay. Sets in mathematics are an organized collection of objects called elements. They are noted mathematically by curly brackets. Okay, so this is curly brackets. Elements of sets can be represented using various notation, the roster or the set builder. And we will return to this later. Okay, next, representation of sets. There are various ways sets can be represented. The fundamental difference is the way the elements are listed. They can be represented by either semantic, roster, or set builder form. Okay, semantic form of representing sets. This notation is a statement form of describing the elements of a set. For example, we can list natural prime numbers below 20. Okay, another example is the list of the months in a year. So in semantic form, they can even be written as a set of odd natural numbers less than 10. Okay, next, roster form of representing sets. The roster form is the most commonly used notation used for sets. Elements are denoted by curly brackets and separated by commas. With this type of notation, the elements of the set are usually mentioned. For example, a set of natural numbers below 10 will be set A, which contain the elements 1, 3, 5, 7, 9. Okay, equating A to our set means that anywhere we find A, we are talking about our list of odd natural numbers. In another instance, you have a set with infinite elements, which is usually expressed with a series of dots at the end of the last state element. For example, a set of positive integers will be denoted by so this means there are endless numbers following 5 in the order that has been already expressed. Okay, next, set builder form of representing sets. This mathematical notation is used to describe sets by demonstrating the properties that its members must satisfy. There is usually a statement that specifically describes the common feature of all the elements of set. Okay, for example, a set of positive integers up to 5 can be denoted by the set builder as like this, and so is the set of all x such that x less than or equal to 5. Okay, another example could be A. So A is the set of all x such that x is an even number, x less than or equal to 12. So this notation states that all the elements of set A are even numbers that are less than or equal to 12 Okay, by writing this in roster form, we will have 2, 4, 6, 8, 10, 12. Types of sets. There are many different types of sets in mathematics. We will go over them in this section. Okay, first, empty set. Sets that do not contain any elements are called empty sets or null sets. They are denoted by either like this or this. Okay, example of empty set. Let's set A, which contain the elements. A is the number of students studying in class 6 and class 7. Okay, as we all know, a student cannot learn in 2 classes. So, therefore, set A is an empty set. Okay, next, finite sets. Finite sets are sets with a countable number of elements in them. For example, a set of positive integers below 7 will be set A, which contain the elements 1, 2, 3, 4, 5, 6. Or A is the set of all x such that x is positive integer less than 7. Okay, next, infinite sets. These are sets that contain an infinite number of elements. An example of this set is Z, set of all integers. Okay, another example is multiples of 3, which can be denoted by set C, which contain the elements 3, 6, 9, 12, 15, so on. The series of dots after the last elements listed is used to express its infinite status. Okay, next, subsets. Set A is considered a subset of B if all elements of A are present in set B. It is expressed mathematically by the notation A subset B. Okay, what that notation means is that A is a subset of B. What it means for A to be a subset of B is that any element in A also has to be an element of B. By this definition, sets are considered subsets of themselves. Okay, for example, if set B, which contain the elements 4, 6, 8, and set A, which contain the elements 6, 8. A subset of B because every element in A, that means 6 and 8, are also included in B. Next, equivalent sets. Equivalent sets are sets with the same cardinal number. The elements inside of the set do not have to be the same if all of the elements inside the set are the same. That means that they are equal sets, and equal sets are different than equivalent sets. So equivalent sets, they just have to have the same cardinal number. Okay, so let's look at an example. We're gonna determine if any of the following are equivalent. So set A, which contain the elements apples, blueberries, grapes. Okay, the cardinal number for set A is equal to 3. Moving along, set B, which contain the elements 1, 5, 9, 13. So the cardinal number of set B is equal to 4. Since 3 does not equal 4, A and B are not equivalent sets. And then the last one, C. Set C, which contain the elements A, B, C. So the cardinal number of set C is equal to 3. So we can see that set A and set C, set A and set C have equal cardinal numbers. So we can say that set A and C are equivalent since both have a cardinal number of 3. Okay, that's all my explanation about sets. Thank you for your attention. I hope this lesson has given us new insights on the sets. Goodbye.